Hey class, and welcome to physics. Today, we're getting good at solving word problems using conservation of momentum, inelastic, and elastic. That's using inelastic and elastic collisions. So first we're going to have a quick little review lecture, super fast. Then you guys are going to hit pause on this video, and you're going to take your quiz, which is on Echo. So there should be a few extra Chromebooks in the back of the class just in case. Not all of you have one. Once you are done with the quiz, you'll hit submit. It'll give you a 0. That's just a placeholder. I am going to go through and grade all of the quizzes today. So the 0 is temporary. But as soon as you've handed it in, and everyone in your group has, you can move on and take your notes on elastic collision. This is in addition to the notes you've already taken from the Khan Academy video last week. Then there's a practice problem. That's part of the video lecture. That's in this video. And then finally, case file 3. At the end of this video, I give instructions on how to solve case file 3. So you just keep watching this video, you take the notes on it, you read case file 3, maybe you watch the last bit of this video again, and then the rest of class is case file 3. Remember, at the end of today, I need to have reports for case file 1, case file 2, and case file 3 done and handed in. They will all be graded and part of your grade for this progress report. All right, let's go ahead and get started, shall we? Inelastic and collision review. That's too far. There we go. Inelastic and explosion review. All right, so an inelastic collision is where two things come together, they stick, and then they move off together. We call that inelastic or sticky. That means that you have two masses before, one mass, two mass, and two velocities before, one velocity, two velocity, but only one mass and one velocity afterwards, where VA means the velocity of A, velocity of B, velocity final, or after the crash. So here, just by looking at the equation, I can see that I have two things before and only one thing after. An explosion is the exact opposite. It's where I have two things that are together as one, and then they come apart. So if I look at my equation, I see I got one thing before that becomes two separate things after. So the example here would be if I'm standing on a skateboard and I jump off the skateboard, I go one way, M-A-V-A, and the skateboard goes shooting the other way, M-B-V-B. So here's the velocity of both together initially before the crash. Here's VA, velocity of A after the crash, velocity of B after the crash, or explosion in this case. All right. When you are doing these problems, make sure you draw a picture. Draw the arrows. And whenever you have an arrow that goes to the right, make sure it is positive. And whenever you have an arrow that goes to the left, make it negative. This is going to be especially important on the quiz. I'll tell you right now from the other two classes, the number one mistake people were making was they were forgetting the negative. Everything else about their work was correct, except the negative. All right, now there are two typos on the quiz before you get started. No, exam prom, whatever, we'll skip it. There are two typos on the quiz. I forget to tell you the mass of the surfboard, and I forget to tell you the mass of the bowling ball. There is one problem with a surfboard. The mass is 5 kilograms. There is one problem with a bowling ball. The mass is 4.5 kilograms. That's it. You are now ready to take the quiz. So go ahead and hit pause. On Echo, go to the quiz and take it. Remember, when you are done, it will give you a 0 until I grade it, which I will do later today. You still listening? Okay, that means you're done with the quiz then, right? Yeah? Okay, well, the bell rang, so I guess that means that you're done with the quiz. So let's now move on and talk about elastic collisions. I believe you took notes on elastic collisions on page 50. I might be wrong on that, though. An inelastic collision is where two things come together and become one thing. An elastic collision is where two things come together, bounce off each other, and are still two separate things. Check out the pretty picture. They're coming together, smack, they come apart. So our equation for an inelastic collision is going to be this, where I have two things before the crash and two things after the crash. But it follows the exact same pattern. The total momentum before the crash must be equal to the total momentum after the crash, where the momentum of A before the crash is going to be ma VAI, velocity of A initially, plus the momentum of B before, mb VBI, velocity of B initially. And whatever that total number is, it must be equal to this total number, which is going to be ma times VAF, velocity of A final, plus mb VBF, velocity of B final. Now, if this is the picture, notice that right here, VBI is going to be negative because it's going to the left. And over here, VAF is going to the left. So it is also going to be negative. All right, example problem time. Two pool balls of mass 0.16 kilograms are rolling towards each other. Ball A is rolling forward at a speed of 2 meters per second, while ball B is rolling at a speed of 0.8 meters per second. The two collide and bounce off of each other, each ball changing direction. After the crash, ball B is rolling at a speed of 2.5 meters per second. What is the velocity of ball A? All right, well, let's see. We read the problem. What do we do next? Oh, we read the problem again and annotate it. We underline all the important stuff. Well, let's see. The mass is important. That they're rolling towards each other is important. The speed of 2 and the speed of 0.8, those are important. That they bounce off and change direction, that's important. Speed of 2.5, and what is the velocity of ball A? Shabam. Those are the things that I would call important. And now using just those underlined things, I'm going to make my picture. All right, so I have two pool balls of mass 0.16 kilograms, and they're going towards each other. All right, I got that going on. Then they bounce off each other, and they change direction. Okay, so the arrows have changed direction. Good. Now I'm ready to put on my numbers. I know the mass is 0.16 kilograms for each. I know the speed of A before is 2. The speed of B before is 0.8. And the speed of B after is 2.5. Now I look at my arrows. Okay, this is to the right, so positive. To the left, so negative. To the left, I don't know what it is, but whatever it is, it's going to be negative. And this is to the right, positive. I've read the problem. I have annotated the problem. I have drawn the picture. I am now ready to do some algebra. So, shabam. Here's my equation. MAVAI plus MBVBI equals MAVAF plus MBVBF. And if I write it like this, I'm literally just going to take the numbers and plug them in to the term that is right underneath it. And I get this beautiful piece of work. All right, simplification time. I see this can be combined, this can be combined, and this can be combined, which gives me shabam. Because 0.16 times 2 is 0.32. 0.16 times negative 0.8 is negative 0.128. And then this gives me 0.4. Okay, 20 seconds left. Let's make this fast. That gives me that, which gives me that, which gives me that. All right, I will have a second video underneath this one that will have the instructions on how to solve case file 3.